A signal condition system is the one in which the signals that are coming from the transducer, which is equivalent to that of the physical quantity which is measured by the transducer, has to be controlled. At the same time, has to be modified. Okay, or otherwise has to be uh, has to be processed. So as per the requirement in the last stage, as per the requirement in the last stage. So which is referred to nothing but the signal condition system. Okay, so that means that first of all we have to take the physical quantity. A physical quantity nothing but the measured quantity, and first thing is it is detected by the first stage of instrumentation or a measurement system, which is nothing but a transducer stage, which is nothing but a transducer stage. Okay, this transducer will detect the quantity, and it is converted into an electrical form. In most of the cases, the transducers will convert into the electrical form. So that means that this electrical form has to be modified further. That means that in order to have sufficient signal, in order to have that sufficient signal to drive the signal indicating stage. The signal indicating stage is the one which is there in the last stage of the system. So signal indicating stage implies nothing but it may be a display device, or it may be a voltmeter, or it may be any other computer hardware. Okay, like that. So that means that so the output of the first stage, which is the transducer, has to be modified. So in order to drive the signal indicating stage, so which is present in the last stage. So where the last stage may consist of an indicating device, a recording device, a displaying device, or it may be a data processing device, that is elements, and it may have a control elements. It may consist of control elements. So therefore, in overall measurement, especially in electronic aided measurement, the quantity is converted into electric signal, and then it is amplified. Sometimes there is no need for amplifying, so therefore it is modified. Okay, so in order to operate the display devices, and now the output of the display device will be a numerical value. The output of display device will be a numerical value, which is proportional to that of the measured quantity, which is proportional to that of the measured quantity. So that constitutes nothing but a signal condition system. So let us see the block diagram here, which is nothing but electronic aided measurement system. So in electronic measurement system, we have the physical quantity, so which is referred to as light, so temperature, etc. And this is detected by the transducer. So like photo device, that a photo device might have photo transistor, etc. like that, and photo multiplier and the thermistor bridges electrodes. So that means that the photo detector, and we have a thermistor, and we have the pH electrode, glass pH electrode in case of pH measurement, or it may be a strain gauge in case of change in temperature is reflected on the change in resistance in the bridge. Okay, and this is converted into a measured electrical signal. So the measured electrical signal is converted by means of electrical signal modifier, where this is nothing but an electronic circuit, and this circuit mostly is nothing but a amplifier circuit. The circuit is mostly nothing but an amplifier circuit. So in case of amplification, so if the required signal has been obtained from the output of the bridge, implies nothing but we may directly converted the circuit into the another type of signal. So that is by using the lock circuit or by using the integrated circuit like that. Okay, and finally it has to be given to that of the last stage, so where we can have recorder, meters, display device, and we have a digital printer. So that is the readout devices, which are referred to nothing but the readout devices. So this is the simple electronic aided measurement. So my main thing is that we have to concentration on the middle one, that is the modifier, the signal modifier, that is signal condition. So this is what we have to think in mind here. So the thing is that here the amplifier that is used will have certain parameters, and that based upon that parameters, and the signal has been modified. Okay, so coming to the actual thing, so that is what we discussed. The input device, which may be a photo detector, thermistor bridge, a glass electrode, pH electrode, or strain gauge, so in which the signal is converted into electrical signal. So what is the electrical signal compresses of? So this electrical signal compresses nothing but the information of the physical quantity. It compresses the information of the physical quantity. That means that it represents the information of the physical quantity. Okay, so now this electrical signal is now encoded or modified with suitable electronic circuit. Here the electronic circuit we generally use nothing but a amplifier, in which the output of a transducer, which is nothing but a very low signal, and this low signal cannot be sufficient to drive the last stage of the system. The last stage of system, we have some recorders, we have display devices, it may be a computer, etc., where these signals cannot able to detect those devices. So for that purpose, we have to amplify this device. For that purpose, we have to amplify this device. So the electronic circuit, which is nothing but an amplifier, will have certain adjustable parameters like zero, offset voltage, and standard deviation, position, etc. And sometimes may use the compensation techniques like, for example, in terms of temperature variations, we have to need for temperature compensation techniques, and for non-linear variations, we have to use some compensation techniques, in which the input device, that is the transducer, should read the input signal, that is the physical quantity, accurately. Okay, that means that whenever the output of transducer is given to the amplifier, this amplifier amplifies the input signal that is coming from the transducer, and later it is given to the last stage of the system. Okay, so in the last stage of system, we have the readout device. Ultimately, at the end, the measurement is a number. That is, the end result is nothing but a number. So this number is obtained from where the output devices, like the display devices, like that is not what we have: digital display, a digital printer, it may be a meter. In the meter also we have certain scale. The scale will have certain number. So that means that the physical quantity is converted into the last is nothing but a number. Okay, and recorder. So recorder is also nothing but a chart. The recorder is nothing but a chart. So according to the change in physical quantity, there will be chart that is present in the recorder. So ultimately, the physical quantity is converted into the number at last. Okay, so this is how the system is, that is the measurement system is compresses of. Okay, so now, so what happened in this measurement system? Here, the one signal has been converted into different types. Okay, at least three differences has been taken place. That is, it was the physical quantity has been encoded in three different forms. The first thing is the physical quantity or chemical quantity is converted into the electrical signal, and finally it is converted into the number. So therefore it was encoded a minimum of three times. Okay, so therefore in each way, so data is encoded. In each way, data is encoded, and therefore it is called as data domain. And therefore it is called as data domain. So that means that here the measurement data, so which is represented by instrument, so like a physical quantity, a chemical quantity, so is converted into the electrical signal, that is first time. And next, the electrical signal is again converted into a represent data, converted into a property like number. So therefore here the data is converting. So data is encoded several times, that is approximately 2 to 3 times, and therefore it is called as data domain. Okay, so in order to measurement these things, these physical quantities, so there should be the output. The output may of some different types. It may be analog output, it might be of digital output. Okay, so therefore in intermediate stage, so we will have a signal conditioning stage such that the data may be converted into analog form or it may be in the digital form. Okay, so as per requirement in the last stage. Okay, so therefore the intermediate stage will have a signal conditioning stage in which it performs certain processes. So these processes are referred to nothing but linear processes or non-linear processes. So when coming to the linear processes, so it is nothing but an amplification. It may be amplification, it may be attenuation, it may be integration, where the one type of signal is converted to the other form. For example, if it is a square wave, it is converted to the triangular by integration. Similarly, differentiation, and sometimes what will happen, we have n number of transducers, we have n different input signals, and that input signals has to be added. So for that one, we have the addition, and otherwise nothing but subtraction. Okay, so therefore, the signal condition equipment can perform two types of operations, that is process. So likewise, linear process and linear non-linear process. The linear process where we can have the amplification, attenuation, integration, differentiation, sometimes addition or subtraction. Okay, so why you go for amplification implies nothing but, so whenever the output of the signal, the transducer is very low, so therefore we can go for amplification. So the output of the transducer or from the bridge circuit is having some disturbance, is having some spikes like that. So we have to attenuate the uh, unwanted signal. We have to attenuate the unwanted signal and to have to take the average of the normal continuous signal. So for that one, you can go for attenuation, like integration, converting, differential is also converting, adding of the two signals from the transducer, or subtraction. So subtracting the two signals from the transducers, which constitute nothing but the linear process. When coming to the nonlinear process, so such as modulation, so demodulation, sampling, filtering, clipping, clamping, so which are nothing but the nonlinear process. Okay, so that means that it may be multiplying, squaring, linearization, etc., which performs the nonlinear process. So in order to perform this process, the components that we have to select should be proper. The components in order to have this process should be proper. Okay, so proper means for what type of for what type of signal converting, we have to choose the components. So we have to choose that respective components only in order to produce the faithful reproduction of the signal. Faithful reproduction of the signal. Okay, so that is the more important one. That is means the signal condition system or the signal condition equipment is the one which perform some tasks on the signal that is measured, the signal that is measured by the transducer. Okay, so that means that the signal condition system is the ultimate, plays an ultimate role in such a way that, so after converting the signal as per a requirement, okay, so it can be displayed very easily. Okay, so here are the things. So in the same signal condition system, or it may be a DAC acquisition equipment. So we have transducers. Anyway, we have the transducers in the first stage. So we know that these transducers are of different types. One is active transducers, another one is passive transducers. So in order to use the passive transducers, we need some external source. So like the bridges. Why? Because these passive transducers cannot convert its signal directly into the electrical form. So it requires some external DC source. So therefore, at the same time, the output of these bridges may not have a large values. So again, this has to be amplified. So therefore, whenever you use a passive transducers, an excitation source is needed, and the same time, the amplification also needed. Similarly, when you go for active transducers, so we know that like piezoelectric crystal, okay, which refers to nothing but an active transducer. So it directly produces the voltage, and we know that the voltage is supposed to be from 1 volt to up to maximum of 30 millivolts. Okay, so which is very low signal. So that low signal cannot drive the final stage. So which is nothing but the display devices. Example, for example, take display devices. So in that case, we need amplification. In that case, we need amplification. So therefore, in both of the cases, in either active devices, active transducers, as well as passive device, passive transducers, so the output has to be leveled. The output has to be leveled to the required level, and therefore we have to do conversion, we have to do processing, we have to do indicating, and we have to do for recording purposes. So that means that the output of transducer has to be brought to into the usage for conversion, for processing, for indicating and recording. So here, that is, the passive transducer needs excitation, whereas the active transducer needs amplification. Simply, passive transducer needs excitation and active transducer needs amplification. Okay. Here, the excitation source may be a DC source or it may be a AC source. It may be a DC source or it may be a AC source. So this is what about the a signal condition system. This is what about the signal condition system. So coming to the overall view. So coming back to again to a signal condition system, we have a physical quantity that has to be measured in the first stage. So which is nothing but the transducer stage, and the transducer is the one which detects the physical quantity and converted into the electrical form. Okay, this electrical form may not be sufficient to drive the last stage, and therefore the signal has to be modified or the signal has to be amplified. So this is done by the signal condition system, and therefore a signal condition system or the electronic aided measurement will have this function, that it is a physical quantity is measured and later it is measured by the photo devices, photo multiplier, etc., and it is given to the signal condition system where the signal has to be converted in different forms. So by different forms, like it may be amplifier, it may be modifier, and finally it gives to that of the display device, that is the output devices. Okay, and now, so anyway, the transistors that are used here. So the ultimate result, the final result is nothing but a number. That is, the physical quantity has been converted into the number. Okay, final device. So therefore, we have three processes. At least we have three modification has been done here. That is, the physical quantity converted to electrical, and electrical is may be modified, and it may be converted to the number. And therefore, in all the cases, the data as the representation of information has been changed, and therefore it is called as data domain. Therefore, it is called as data domain. So this data may be of analog or digital, and that is based upon the signal conditioning stage. So the signal condition stage is the one in which it performs some operations, that is process. It is linear process or non-linear process. Okay, so in order to function these processes, so we have to select the perfect components for perfect process. Okay, so therefore in this signal condition system we are using the transducers. So the transducer may be passive or active. So we know that the active transducer there is no need for any excitation, whereas the passive there is need of excitation, and this excitation source may be a DC source or it may be a AC source. And this based upon this one, the signal condition system is of two types. So that is DC signal condition system and AC signal condition system. So in DC condition system, the transducers that we are using is nothing but the resistance transducer. So anyway, this resistance transducer is nothing but a passive transducer, and therefore it needs a DC excitation source, and this transducer is there in any one of the arm of the Wheatstone bridge, and therefore the bridge is excited by a DC source. So now in order to make the bridge balance, we can use a potentiometer such that when there is no any physical quantity change, the bridge is said to be balanced, and whenever there is a change in physical quantity, so therefore the bridge will be unbalanced, and in this unbalanced condition the bridge will produce some output voltage, and then the output voltage is calibrated, or it may be uh, given to the DC amplifier. It may be given to the DC amplifier. So what this DC amplifier will make? So calibrations during network imply nothing but the output of the bridge circuit is given to that of the DC amplifier by having the zero offset. By having the zero offset exactly. That is nothing but zeroing network. Okay. So the DC amplifier should have certain characteristics like it should have high CMRR and it has good thermal and long stability. It can be easily to calibrate at low frequency, and it is able to recover from overload condition like an AC system. It can be easily recover from an overload system. So this is the properties of a DC amplifier. We know what is the amplifier. The amplifier has certain properties. So in that properties it should have high CMRR. That means that the noise should be reduced, the noise should be rejected, and it should have good thermal and long-term stability. That means that whenever there is a change in temperature, the performance of the amplifier should not change, and at the same time it is used to calibrate at low frequency, and it has to be recovered from the any overload condition. So these are the main requirements of a DC amplifier. So in this system, the problem is nothing but the drift. The problem is nothing but the drift. So drift is nothing but, so whenever the output of the bridge is connected to the DC amplifier, if at all any DC component is present in the output of the bridge, that will be further amplified by the DC amplifier. And therefore what will happen, the output will have some data. So we'll have a spurious signal data. Spurious signal is nothing but the unwanted signal. That is unwanted data is present at the output side. So that is in case of DC condition system, DC signal condition system. That means that in order to avoid that one, we have to use a low drift DC amplifier. Special low drift DC amplifiers are used in case of eliminating the drift problem. Okay. And finally, the output of DC amplifier is given to a low pass filter in which it eliminates the high frequency components or noise that are there from the data signals. So this is the DC amplifier. That is DC signal condition system. Similarly, AC signal condition system. In AC signal condition system also we have transducers. Here we are using a variable resistance transducers or variable inductance type transducers. Here the bridge is excited by a carrier signal in which it has a frequency 50 kHz to 200 kHz. And this carrier, we know that carrier signal frequency is somewhat greater than that of the input signals. Greater than that of the input signal. That means it should be at least 5 to 10 times greater than that of the signal frequency. Here, the output of the transistor is applied to the bridge circuit, and the output is nothing but a modulated carrier signal. Why? Because the carrier signal is given to that of the bridge circuit. So the output is nothing but an amplitude modulated carrier signal. This amplitude modulated carrier signal is further amplified by AC amplifier, and it is given to the phase sensitive demodulator. So this is the phase sensitive detector or demodulator, where we can give the signal that is amplified from the bridge circuit, that is to the phase sensitive detector. So this phase sensitive demodulator detector signal is itself the carrier signal. So here, why are you going for using low pass filter is nothing but, so low pass filter is the one which allows only the low frequency signals, and the high frequency signals is nothing but the carrier signal, and this carrier signal has been completely eliminated, and therefore the low pass signal, which is nothing but the which is equal to that of the physical parameter that is measured, is allowed by the low pass filter, and finally we'll get the output. So that is how we can have the data AC signaling condition system. So here the low pass filter, we are using nothing but active filters, so which rejects this frequency, and it also have the advantage that it prevents overloading on the AC amplifier. So finally the function of the Phase sensitive data is nothing but it is to filter out the carrier frequency component of the data signal. It is to filter out the carrier frequency components of the data signal. So this is the two data signaling condition system, that is DC and AC condition system. And what are the signal that is coming from the output? It may be of any type. So for example, in DC condition system we have a DC signal. For AC condition system we have a AC signal. And what about for digital signal? What about for digital signal? So in either the case, the output is not a digital signal. So in order to have the digital signal, in order to process the thing, we have to further given this signal to the other type of circuit called data acquisition and conversion system. We have to give the signal for data acquisition and converting system. Okay, so let us have the same thing, data acquisition and conversion system. So in this one we have three main uh, main units. One is sample and hold circuit, and one is analog multiplexer, and which is connected to the analog to digital converter, and a control unit. So this control unit is the one which controls all the three parameters, that is A to D converter, analog multiplexer, and as well as sample and hold circuit. So we know the function of sample and hold circuit. So the sample and hold circuit, what it will do, it will samples the various inputs. So that is coming from the different conditional system, different signal condition system, and in a specific time samples the signals coming from the different condition system in a specific time and holds the voltage levels and holds the voltage levels. So until what? Until the analog multiplexer performs the time division multiplexing. Until the analog multiplexer performs the time division multiplexing. So where it will perform the time in the time division multiplexing. So in between the different data inputs, in between the different data inputs. For example, a signal is coming from the first sample and hold second. The same signal is given to the analog multiplexer. It is converting. By the time, so what will happen? The signal coming from the sample and hold circuit in the second signal is hold for some time. So once the conversion is over, then the signal is released again. So like that it is converted. And finally, if you want a digital output, so we can convert the analog signal into the digital output via A to D converter. And we have the control units. So this control unit controls the all the parameters like sample and hold circuit and analog multiplexer and analog to digital converter. This is how the data acquisition and conversion system. So on the whole, so we have DC systems and AC systems and conversion system. So DC systems are generally used for common resistance transducers like potentiometer, resistance strain gauges, etc. Similarly, AC systems are used for variable reactance transducers for the system where signals has to be transmitted via long cables and to the transducer to the signal condition equipment. Okay, so here the thing, the physical quantities like temperature, pressure, strain, acceleration have transduced into their analogous electrical form, amplified, okay, to certain levels, and further processed by the signal condition system and applied directly to the indicating devices or record devices or control systems. Okay, this is how the signal condition system will works. Okay, and if you go for the next thing in plan, nothing but will come. So what are the components that are there in signal condition system? First one is nothing but amplifier. The amplifier that we are going to use is nothing but which is having high CMR or nothing but a op amp. High CMR amplifier nothing but an op amp. So we can go for all the op amp properties. So which type of amplifier that we are used, that is based upon the type of application. So based upon the type of application, you can go for different types of amplifiers. Okay, so similarly the filters. Similarly, which type of filters? So everything will comes under the signal conditioning system. Okay, and this is about the signal condition system. Okay, so physical quantity converted to electrical, modified or amplified, and finally given to the output stage, that is lost. Okay, and this is the main thing. Now this is of two types: DC signal conditioning system and AC signal conditioning system. So anyway, output is nothing but a number, and this number, in order to have a digital format, again we have to go for data acquisition system. Data acquisition system, where it converts into the analog signal to the digital signal. Okay, so that is out about the signal condition system. So in this unit, so what we have learned is nothing but we have learned what is meant by transducer. We have learned what is meant by transducer, and what are the different types of transducers, and measurement of different parameters like displacement, force, pressure, temperature, velocity and acceleration. So velocity, acceleration, vibration, pH measurement, and finally signal conditioning circuits. So this constitutes nothing but the unit 5, and now we have completed our syllabus. We have to completed our syllabus. Okay. So anything you want, you can share me. ఎవరో మాట్లాడొచ్చండి, సిలబస్ కంప్లీట్ అయిపోయింది కదా.